now we do the projection of the straight line. So a straight line is the shortest distance between the 2 points basically. So the projection of the straight line may be drawn by the joint respective projection on the ends which are point. The position of the straight line may also be described with respect to the two reference plane. It may be parallel to one or both the plane. Secondly, contained by one or both the plane, perpendicular to one of the plane, inclined to one plane, parallel to other, inclined to both the plane, projection of line inclined to both the planes, and line contained by plane perpendicular to both the reference. Okay. So first we go to the line parallel to one or both the plane. Now you see here AB line. First we consider the AB line. This is the HP and this is the VP. Okay. So AB line is parallel to the HP. So what will happen? And an angle with the VP. So first we draw the AB. So AB will be this line. Okay. So when you see it from the top view, this is the AB line. And if you see the front view, if you project it, so you get A dash and B dash. So for this, you see in top view, when the line will be parallel to the HP, the top view we get the actual dimension. So first we draw the actual dimension of the AB. In angle is given. So according to the angle given with the XY line, we draw the first AB. From the AB, we draw a perpendicular line. We draw the perpendicular line, and here this distance, and this distance must be given. Okay, this distance means with respect to HP how much height, and from the VP the point A will be given, the position of the point. Okay, and angle must be given. So for this, first you draw the AB. Now each point you draw a vertical line and you get the A dash and B dash. And similarly, if you see the shadow, now a line will be, suppose this is the line. If you just lighted on this object, so what will happen? The shadow will be A dash and B dash. So it will be lower than the AB. So how can you get it? First you draw the AB. From this you get the A dash and B dash. Second case, you see, it will be CD parallel to the VP, means angle parallel to the VP. Any angle parallel to the VP. So first we draw the front view. Here we first we draw the top view, and here it will be first we draw the front view. And from the, if we project it, we get the top view CD. Means here the CD value will be less than the capital CD. Okay, small CD value less than the capital CD. Means front view CD, we draw this, and then we get the CD. And here second one is the line EF is parallel to both HP and VP. So from both sides we get the same line, EF and E dash, same distance, because it is parallel to both. Okay. Clear? Then line contained by one or both the plane. So first line AB is in the HP, and so first line AB on the just HP. Now it will be just like this. Okay, it will be like this. It's like this on the HP. So if you from the front view, we get the smaller than the edge AB. If you front view means from this. So what will happen? For this, first we draw the top view AB in angle given. Then from this draw the position on the XY line, because it is on the HP. Okay. Similarly, if the CD line on the VP, then its top view on the XY line and front view on the VP. So it will be the CD, and the arbitrary distance C dash must be given. Or if the distance is not given, you choose any arbitrary distance. And it is both the EF and both the plane. So this will be the this is straight line on the same plane XY. So means when a line is contained by a plane, its projection on that plane is equal to its true length. When its projection on the other plane is in the reference plane. Means its projection, suppose it is the HP. So its projection on the VP, it will be the lower. Means on the HP, it will get the true length. Similarly, if it is on top view, sorry, from a vertical plane, so what will be its true length is getting on the front view, on the vertical plane. Okay, clear. So this is about the line containing by one or both the plane. Secondly, line perpendicular one of the plane. Means firstly line AB is perpendicular to the HP. So what will happen? If the line will be the perpendicular to the HP, means this is the AB. Perpendicular on the HP means this angle will be the 90 degrees. So top front view we get the line AB, and top view we get a point. So this A and B on the same point, and A dash B dash will be the front view. If line is perpendicular to the VP, then so its top view will be the line CD, and its front view will be the CD. And if we rotate the HP, we get this type of projection. Means according to the XY, if we rotate it, so this CD will be, means if we rotate it, suppose if we rotate it in this direction, so what will happen? This CD portion will be rotated and it will be comes like this. So this is the D roll, means comes like this. Clear? So means when a line is perpendicular to a plane, its projection on that plane is a point, while its projection on the other plane is a line equal to its true length and perpendicular to the reference. In fourth case, inclined to one plane and parallel to the other. So here, first we consider a line PQ. PQ, here you see with the angle theta with the HP. Okay? So first we draw PQ1. So this is the PQ1 makes its projection on the HP. PQ1. This is the angle. So it will be like this. Now you see, suppose this is on the HP, this is vertical plane. So it will be like this. Plane will be like this. And it is parallel to the VP and theta with the HP. Okay. So here first what we do? First we draw the angle theta. So first we draw the front view, P dash and Q1 dash. First we draw the front view. Now from this front view, we get just draw a vertical line and we get P and Q1. So this is the actual top view and this is the front view. So this is when a line will be a angle with the HP. So we first draw the front view. So from this front view, we get the top view. Second case, if a line is angle with the VP, so first we draw the, for this you see, if we like this, so if it is VP, now you see, suppose this is the VP, it will be angle length. Means use true view, means true direction always on the top view. So first we draw the top view and angle will be given. So from this we draw the top view and from this we get the front view and the point position will be must be given. So here the distance of the point R is given and HP from the, and if accordingly you draw the R, first we draw the RS1, then from this we get R dash and S1 dash. Yeah? And the angle phi is given. So when the line is inclined to the HP and parallel to the VP, its top view is the shorter than the true length, and but parallel to XY. Its front view is equal to its true length and is inclined to the HP. Inclination with the HP. And when the line is inclined to the VP and parallel to the HP, its front view is shorter than its true length, but parallel to XY. Its top view is equal to its true length. And means when a line is inclined to one plane and parallel to the other, its projection on the plane to which it is inclined. And its line is shorter than its true length, but parallel to its reference. Okay? So is some example. So a line PQ 90 millimeter long is in the HP and makes an angle 30 with the VP. Its MP is 20 millimeter in front of the VP. Draw its projection. Means its front view means point P is 20 millimeter in front of the VP. Means if we see, means suppose if we the diagram HP and VP, position of the HP and VP. So this is the XY. So point P is in front of the VP. Means suppose this is the 20 millimeter. This is the 25 millimeter, and this is not given on the HP, so this is on the HP. So means we can consider the front view on the XY plane, and Q also on the XY plane, Q dash, and its P will be the 20 in front of VP, means its top view will be, if we rotate it, it will be the 25. So for this, the distance from the xy, this point P position will be 25 meter, and angle will be given. This is 30 to the AP. So first we draw the top view. This is 30 degree. First P and Q, and from this we draw P dash and Q dash. Then just previously a length of the top view of a line parallel to the VP and incline 45 degree to the HP is 50 millimeter. One end of the line is 20 millimeter above HP and 25 millimeter in front of VP. Means 12 millimeter. For first angle projection, if 12 in above HP distance is given, means this is the front view distance. Remember this. Above HP means this is the front view distance in first angle projection, and below HP means it is the front view will be below given. So here 12 millimeter above HP means front view A dash will be 12 millimeter above, and 25 millimeter in front of VP means 25 millimeter below XY line, the top view. Clear? Means any object if X millimeter above HP is given, so means its front view X millimeter above, and if it is Y millimeter front of VP means its top view will be Y millimeter below XY line. Clear? Remember this. So first we draw the position of the point A and A. Then here it is the parallel to the VP and incline 40 to the HP. So means your two section you get the front view. So first we draw the front view, A dash and B dash, angle is given. So from this at each point we draw the vertical line and we get A and B. Next, line inclined to both the plane. So I will discuss the line inclined to both the plane when we discuss the problem. So first we go to the problem. Okay, see the problem number 2. A line GH 50 millimeter long is inclined to VP at angle 45 degree and parallel to the HP. Draw its projection. So basically the line is an angle with the 45 degree and parallel to the HP. So in this case, in top view we'll see the actual dimension. Basically this is angle with the 45 degree and parallel to the HP. So in top view we see the actual dimension. So first we draw the top view, and now if you see, suppose this is the VP, plane, and it will be angle 45 degree with this. Okay, so in top view we'll see that, and if we rotate it in top view it will be like this, angle with this like this in front a top view, and if we rotate it you see like this. Okay, and in front view you see the, because it will be in angle with the VP, in front view you see the less dimension of the actual dimension. So first we draw the top view, and then from this we draw the project and we get the front view. If it is angle with the HP, so then if it is suppose angle with the HP, then its front view you get the actual dimension, and from this we get the top view. Clear? Now in this problem, it is given the line GH 50 millimeter long is inclined to the VP. So first we draw the XY line. First we draw the XY line. Okay. Now here the GH point is not mentioned, so you can draw from this XY line, or you may some gap. So this is X, this is Y. Now we from top view what we'll do, we draw a line 45 degree with this XY line and measure 50 millimeter. So first we draw a line 45 degree and this is the 45 millimeter. Okay. And this distance will be the arbitrary distance. Okay. Now, so this point will be the, because this is top view, we write this is the small g and this is the small h. Okay. And this GH will be the 50 millimeter, because in top view we'll see the actual dimension. Now from each point G and H we draw the projection, the vertical line, perpendicular line, and here also from H So this will be G dash and this will be the H dash. In front view, we always dash means front view, any point. And when you give the dimension, now if we draw the dark line, so this will be the darken, must be darken. This part also be dark. So this is the top view, this is the front view. And when you give the dimension from this, draw a, because this is 45, draw a line 45 degree. Here also draw a 45-degree line. And if we use the unidirectional line, so this will be the position of the 50 will be at the middle of the line. You just erase at this portion, write 50, and here you draw the arrowhead. According to the 3:1 ratio. So this is the projection of the problem number 2. So at problem number 3, a line PQ 60 mm is length is inclined 45 degree to the HP, 30 degree to the VP. One end of the line P is 15 mm above HP, 25 mm in front of the VP. Draw the elevation and plan of the line. So here the line will be inclined with both the plane, HP and VP. Okay. So for this, we do the one by one, step by step. Okay. So first, what we'll do? First, we draw a line XY. Okay. We draw a line XY. So we draw a line XY and give the name. This is X. This is Y. Okay. First, we consider the, you see the point projection of the point P. P is 15 mm above HP and 25 mm in front of VP. So I will tell you in first angle projection, if the point position is given X millimeter above HP, A millimeter above HP and B millimeter in front of VP. So means A millimeter, its front view will be the A millimeter from XY and its top view will be the B millimeter below the XY. Clear? So first we draw a two horizontal line. So here we draw a line of 15 millimeter and another line, this is 25 millimeter. So this will be the 15 and this will be the 25. Why take 15 and 25? You see in problem P is 15 meter above HP, means its front view 15 meter above XY. So this will be the P dash and this is the P. Okay. So and its top view 25 meter below XY. Okay. So first we draw the position of the point P. Now first we consider it is 45 degree to the HP. So in 45 degree to the HP means its top view we see on the actual dimension of the line. So here at this point we draw a 45 degree line. We draw a 45 degree line and measure it will be 60 millimeter. So P dash Q dash, if we consider this will be the, suppose this will be the Q1 dash. So P dash Q1 dash will be the 60 millimeter and this angle will be the 45 degree. Now it is 45 degree with the HP. So its top view will be there on the HP. So this will be a straight line and it will be less than P dash Q dash. So now here we draw a vertical line. So this will be Q1. So this will be the front view P dash Q1 dash and PQ1 will be the top view when the line will be 45 degree with the HP. Clear? Then line will be 30 degree with the VP. So here line will be angle with the both the plane as well as VP as well as HP. So first we one by step one by. So first a line will be 45 degree to the HP. So in 45 degree HP, its front view will be, we get the actual dimension. So first we draw the front view. From this front view, we get the top view. Yeah. So this P dash Q1 dash for the front view, and from P dash, first we draw the 45 degree line, measure 60 millimeter, cut it here, and we get the Q1 dash point. Now from P dash we draw a vertical line, it will be point P, and from Q1 dash we draw a vertical line, so this is the Q1. So this is the projection of the line 45 degree with the HP. Now the problem is the line PQ 30 degree with the VP. So at this point, so in 30 degree with the VP, previous problem we saw in 45 degree what will be the projection. So here this is 30 degree to the VP. So at top view we get the actual dimension. So first we draw the top view. So here draw a 30 degree line. And we measure by compass by 60 millimeter. And it will be naming, suppose this is Q2. So this is the point Q2. So draw a line PQ 30 degree and measure by compass. So this is the 60 millimeter. Okay. Now from Q2, now its front view will be a line. So from Q2, we draw a vertical line up to P dash, this line. So this will be the PQ2 dash. So first what we will do, first we consider there will be no VP, there will be no angle with the VP parallel to the VP, and it will be angle with the HP. We consider this is the projection of the P dash Q1 dash and PQ1. Now we consider there will be no angle with the HP. This will be the parallel to the HP and angle with the VP. Then we get the PQ2 will be the top view and P dash Q2 dash will be the front view. But this will be angle with each other. So we project P dash Q2 dash on this 45 degree line, 45 degree plane. Similarly, here we project basically this P dash Q2 dash will be the front view and PQ1 will be the top view. So we project this Q1 on this PQ2 angle. So this angle will be the 30 degree. So for this, what we'll do at Q1 dash, we draw a horizontal line. And similarly at Q2 we draw another horizontal line. Now now taking the center point P, radius PQ1, we draw a arc. Taking the center point P, radius PQ1, we draw a arc. Similarly, taking the center point P dash, radius P dash Q2 dash, we draw a arc. And you see these 2 points must be in same line, means same vertical line, these 2 points. So if we draw a line P to this point and P dash to this point, so this is the actual top view and this is the top view, this is the front view. So now this is the view will be the P dash Q dash and this will be the P. So this is the top view and this is the front view. So here you write 15 and here you write 25 and here you write 60. Here you write 60 and draw the arrowhead. I do not fill up the arrowhead. All of you must fill up the arrowhead. Okay. According to the dimension, draw the arrowhead. Similarly, here also you draw the arrowhead. And give the angle 45 degree, 30 degree, and here when you give the dimension, you just write the middle of the 25. Here it is problem that there will be no option to erase this part of this line. This is the difficult. So for this reason, we just overwrite on this line. So all of you, when you give the dimension, you just erase at the middle part of the dimension line and then write 60. Similarly here 15, you just erase at the middle part of the line and write 15. Similarly here also write erase the line part of the middle part of the line, then dimension line and write 25. Clear? So this is about the problem number 3. So at problem number 4, a line LN 70 mm long has its end L is 10 mm above HP and 50 mm in front of VP. Its top view and front view measure 60 mm and 40 mm respectively. Draw the projection of the line and determine its true inclination with the H by VP. So basically, in this problem, in this previous problem, the angle of the HP and VP is given, and you have to draw the top view and front view. Yeah. But in this problem, this angle is not given 45 degree or 30 degree. You have to measure this angle. But here the measurement of the top view and front view means here PQ dash or P dash Q2 dash, because this is the same radius. P dash Q dash equals to P dash Q2 dash, or it is given and PQ1 or PQ is given. So first what we'll do in this problem. So first we draw the X line, XY line. First we draw the XY line. First we draw the XY line. Then the position of the L is given. Point A. This is 10 mm above HP, 15 mm in front of VP. Means its top view will be 10 mm, its front view will be 10 mm above XY line, and front view will be 10 mm above XY line, and top view will be 15 mm below XY line. So this will be the 10. So this will be the 10. And this will be the 15. And we write as this is L dash and this is the L. Okay. Now here the front view measures 60, top view measures 60 mm and front view measure 40 mm. So what we'll do, we measure 40 mm by compass and mark the point. By measure 40 mm, we mark the point. So this will be right as this. Suppose M2 dash. So this will be the M2 dash. and similarly its top view is measure 40 millimeter. So front view, top view measure 60 millimeter. So here we mark a point. So this will be the 40 60 millimeter. So this is M1. Basically, if you see this figure, here P dash Q2 dash will be the 40 millimeter, and PQ1 will be the 60 millimeter. It is given in the problem. So L dash M2 dash will be the 40 millimeter, and L M1 will be the 60 millimeter. It is given in the problem. Now, previous problem, if you see, from M2 dash, we draw a line lower side. We draw a vertical line lower side, and from M1 we draw a line vertically upward. Okay. So from M2 dash we draw a line vertically downward direction, and from M1 we draw a line vertically upward direction. Now, in your problem, the length line LM 70 meter long. So what we'll do, in previous problem your angle is given. So first what we'll do, we draw a line angle, so we get the Q1 dash point. Clear? But here how can we get the M1 dash point? So how can we get? So the because it is a angle with the HP and VP, so similar to just opposite to it. So here we get measure the 70 millimeter by compass L dash, and suppose it will be cut it here. Okay, by compass it will be cut it here. So take by compass, take the 70 millimeter, and it will be cut it here and join this. So this will be the M1 dash. Similarly, how can we get the M2? So by taking the measurement will be the 70 millimeter and draw it, and suppose it will be cut it here and draw the line at this point. So this is basically the position of the HP and VP, and you have to measure this angle, these two angles. You have to measure these two angles by protector or by diagonal. Then other remaining same, so this will be the M2. Okay. Now here you draw a horizontal line. You have to draw the vertical. Draw the horizontal line, and similarly here also draw a horizontal line. Now center point L, radius M1, we draw a arc. Center point L, radius M1, we draw a arc. And similarly center point M2 dash, we draw another arc. So now join these 2 points, and these 2 points you see same vertical line. It must be in same vertical line. And this is the name. Dash. and you have to find out these two angles. And basically the angle comes nearby 30 degree, 29 or 30 degree, this angle. You calculate, you get this type of angle. And this will be approximately 55. Okay, you just calculate this two angle, measure the angle. So this is the answer of this problem. So here you give the dimension. This one will be the same 10 and 15. And here from this L M2 dash, just from this, here you can write L dash M2 dash equals to 40 and L M1 equals to 60 and angle M1 dash L dash M2 dash, you calculate it. You have to calculate an angle M1 L M2. You have to calculate. So both angle you have to calculate. And you show the line L dash to M1 dash 70 millimeters, same way. You have to use on the 60, similarly L to M2 also 70, same way.